Now, as you saw in the last video, we started talking about the student t-distribution, which we will just call it a t-distribution. And we noticed that as the degrees of freedom, which is a sample size minus 1, increases, it begins to look more and more like a standard normal distribution. Now, I'm not going to go through this, but it's pretty interesting that the student t-distribution actually was created by William Gossett. Basically, he worked for a brewery, the Guinness Brewery, and again, you can Google him if you want to. It's an interesting story, but how he came up with the student t-distribution. But I'm going to give him credit where it's due that he did create this distribution. Now, the next couple slides basically, again, just reiterate what the student t-distribution is, and from this point on, we'll just call it a t-distribution. But again, it looks fairly unimodal and symmetric, but it has different shapes for different sample sizes. Basically, it's just as the sample size gets larger, it approaches and looks closer to a standard normal distribution, which is here in blue. Okay. For smaller sample size, it's shorter, wider, and thicker at the tails. Now, it's based off of, again, something called degrees of freedom. Degrees of freedom is just a sample size minus 1, and it's very similar to, it's matter of fact, same thing as when we talked about first semester about sample standard deviation, how you had to divide the deviations of each value from the mean by n minus 1. It's the very same thing. So here's, again, a little bit more about that. You can read through this if you like. But again, the thing you have to remember is for a sample size n, degrees of freedom is sample size minus 1. Now, the standard errors we talked about before, we have a little bit of an issue with this. According to the central limit theorem, the standard error should be the population standard deviation divided by the square root of the sample size. What that is, that gives you a measure of the width or the spread of a sampling distribution, which is a distribution of samples and means in this case. However, as I stated before, generally if we don't know what the population mean is, which is what we're trying to estimate, then ladies and gentlemen, we probably don't know what the population standard deviation is either. In other words, we probably don't know what this is. So what we do then to compensate for that is, in place of that, we use our sample standard deviation in place of the population standard deviation, okay? We use that as an estimate. And generally, if your population varies less, that value of S, that sample standard deviation, is going to be pretty accurate. So from here on out, when I talk about the standard error, we are not, ladies and gentlemen, going to use the one from the central limit theorem because we don't know the population standard deviation. This is what we're going to use. We're going to use the sample standard deviation divided by the square root of the sample size. Okay? Now, one other assumption we need to make so we can set these up is that our sample is going to consist of a simple random sample. Okay, all samples are the same size, have the same chance of being selected. And either one or both of these conditions is going to be true. Either we know the population that this is coming from is normally distributed, bell-shaped and unimodal approximately, or if we don't know that, or if it's not normal, in other words, if we don't know this, or our population we know to be skewed, some weird shape, then we have to make sure our sample size is greater than or equal to 30 in order to be able to use the t-distribution. Okay? So this is important. Again, to be able to use this, to be able to set this up, either the population needs to be normal, which means bell-shaped and unimodal, and if we don't know that, or if it's not bell-shaped and unimodal, then our samples that we take have to be larger than or equal to 30. Now, here is just some notation for your benefit. Again, you can look through this. I think a lot of this you already know by now, but we're going to go ahead and use this and in order to be able to set up our confidence intervals. So I think what we're going to do is we're going to go ahead and pause the video here, or not pause it, stop it, and then the next video we're actually going to look and show how to construct a